Welcome back, learners. So as we have said before, we're going to be looking at our second concept, which is now the pH of non-metal oxide solution. So basically, what is going to be the pH when a non-metal oxide is dissolved in water? So let's begin. So the reaction between a non-metal and oxygen produces a non-metal oxide. So we said for us to get a metal oxide, there must be a metal reacting with oxygen to get a metal oxide. So with a non-metal oxide, we need to have a non-metal reacting with oxygen to get a non-metal oxide. So non-metal oxides, they form acidic solutions. So remember, the metal oxides, their solutions are going to be basic because their pH is going to be above 7. So with this one, because they are acidic, then when they are dissolved in water, then they will have a pH that is less than 7. With the metal oxides, their pH is above 7. With the non-metal oxide, the pH is less than 7. So they can also be corrosive if their pH is 2 or lower. So we do know what corrosive means that it can eat away any material and even flesh. So it can cause damage. So the non-metal oxides, when they are reacting with water and their pH is 2, they are going to be extremely corrosive. So we need to be taking care, or we need to be making sure that only adults or under supervision we can be handling the metal oxides as them when they are having a pH that is less than 7 or around 2. So the corrosive property depends on the type and the concentration of the non-metal oxide solution. As we have said, they can have a pH that is less than 7. However, because different non-metal oxides, they can vary in terms of their pH scale or in terms of their pH value. So the concentration or the corrosive property is going to be dependent on the strength and the concentration of the non-metal oxide in the solution. So the stronger it is, the lower the pH that you're going to have, and obviously the more corrosive it will become. So as an example, carbon dioxide and sulfur dioxide, those are examples of non-metal oxides that you're going to be looking at. So the carbon, that's the non-metal, the sulfur, that's the non-metal. When they are reacting with the oxygen, this is going to be forming our carbon dioxide, our non-metal oxide. When sulfur reacts with oxygen, we're going to be forming our sulfur dioxide. So when carbon dioxide now, after it has reacted with oxygen to form our carbon dioxide, our non-metal oxide, when that carbon dioxide is dissolved in water, the reaction that we are seeing here, this is the product of when we are reacting the carbon dioxide and water, we are getting something called the carbonic acid. So the product is called carbonic acid, what you find in our fizzy drinks. When you open a bottle of Coke, that fizziness that you find there, that's our carbonic acid that is found in those products. So this acid or this product is found in all fizzy drinks, as we have said. So you can find it in your Coca-Cola, in your Fanta, in all other fizzy drinks that you drink. They have this particular acid. However, when a small amount of carbon dioxide in the atmosphere dissolves in rainwater, so when we have carbon dioxide in the atmosphere and then it rains, that carbon dioxide dissolving in the rainwater, it gives the pH of about 5 to 6. So the pH of that rain coming down would be around 5 to 6. And we do know that once the pH is less than 7, then the substance is acidic. However, because it's closer to 7, it's around 7, it can be regarded as a weak acid. So the further you move away from 7, as you have said, towards 0, the stronger the substance becomes. So because the pH of this rainwater is going to be around 5 to 6 and closer to 7, therefore it can be regarded as a weak acid. So now that rainwater, after the carbon dioxide has dissolved in that rainwater, that rain is going to be called an acid rain. So what happens now when we are dissolving the sulfur dioxide? Remember, sulfur starts by reacting with oxygen to form the sulfur dioxide, being our non-metal oxide. So now, taking our non-metal oxide and reacting or dissolving that in water, we are getting our sulfurous acid. So when sulfur dissolves in water, the reaction is given here. That sulfur dioxide plus H2O reacts to form sulfurous acid. So now we are saying that the product that you're going to be forming here, it is our sulfurous acid. Now sulfurous acid can have a pH of 2, which makes it responsible for most of the corrosive damage done by acid rain. So when that rain comes down, that acid rain, when it comes down, it can cause a lot of damage in the environment that we're living in. So now, as we're saying that the acid rain can be harmful to the environment, we find that on the zinc, on the corrugated roof that we have in our houses, it can cause a lot of damage. Even on the stones, the decorations that we have outside, the concrete is going to cause a lot of damage. So it discolors them. You find that after some time, that nice decoration that you had outside, it's now green in color. So that is because of our acid rain. So then, acid rain makes the water in the rivers and lake more acidic. So as we have said, acid rain causes a lot of damage in our environment. As for instance, this one here, it makes the water that we find in our rivers and our lake more acidic. And obviously, if it makes it more acidic, it means the pH of that rain, of that lake water, of that river and that lake, it decreases. It gets lower and lower than 7. And as you know, when you're going lower and lower than 7, the stronger the substance becomes in terms of it being acidic. Then above 7, it becomes basic. So now, the soil that absorbs the rain, remember, the rain can go into the river or the lake and can also be absorbed by the soil. So once the soil absorbs that rainwater, then the soil will become more acidic. The low pH is going to kill the plants and animals if they are less tolerant of changes in pH. So once the soil absorbs that acid rain, then the soil becomes more acidic. And if the plants that are around or in that particular soil are less tolerant to the changes in the pH, they're going to die. And also, even we can talk about the ants that are living underneath the ground. When they're also less tolerant of that change in pH, they're also going to die. So not only does it cause damage in the environment, in the decorations that we see, also in our natural substances, our water that we are drinking, and also the plants that we are obviously eating for food. And then also it can also kill the animals that are in our environment. So not only just the man-made substances. So acid rain can also cause damage to the human-made materials like the zinc roofs and structures made of marble or concrete. So as we can see, the non-metal oxide solutions are causing a lot of damage to our environment. So not only that, we also know that even the metal oxides, they are bases, they can vary in terms of the strength, and we know that bases can also be corrosive. So therefore, not only the non-metal oxide solutions are corrosive, even the metal oxide solutions, they're also corrosive. So now we know what happens when a metal reacts with oxygen, it forms a metal oxide. Now that metal oxide reacting with acid, we know what happens. We also know what happens now when our non-metal reacts with oxygen, it forms a non-metal oxide. Then that non-metal oxide dissolved in water, we can have such things called our acid rain, and they can damage the environment, they can make the plants, the soil, the water to be more acidic. So I've said a mouthful. I hope I see you next time. Bye.